Welcome everybody, this is the second variation, or I would say the third variation probably. In this case we will be employing two theorems to find the radii. So this is a center. Let me draw. Alright, so foremost what I wish to do is I would like to, let me name them as A, B and C. So I will drop a perpendicular from A to chord BC. So this is what we have got, right? And I name it as D. So AD is the height of triangle ABC. So let me take it as H. Next, let BD be equal to X. So this means this entire length DC will be from BC you subtract BD. So what is BC? BC is 14 units totally, and BD is X. So this distance is 14 negative X, this distance is X, and this entire length is 40. Okay, looks good. Now clearly the perpendicular dropped will hit the chord BC at 90. So we have triangle ADB to be a right angle triangle. So this means we can apply Pythagoras theorem. So what is that? That means AD squared plus BD squared is equal to AB squared. AD squared is H squared, BD squared is X squared, and AB squared is 13 squared. So H squared is 13 squared negative X squared. So this means H squared is 169 negative X squared. Let me have it as 1. Next we consider triangle ADC. Okay, so clearly the triangle is a right angled triangle. So this means by Pythagoras we have, so what do we have? AD squared plus DC squared is equal to AC squared, right? AD squared plus DC squared is AC squared. So AD squared is H squared, DC squared 14 negative X the whole squared, and AC squared is 15 squared. So this is 225 negative of 14 negative X the whole squared is equal to H squared. I take this as 2. So 1 and 2. From 1 and 2 we get, or we have, or we got, whatever you want, you state it there. So 169 negative X squared is equal to 225 negative of 14 negative X the whole squared. This is 225 negative of, expand this, 14 squared negative 2 times 14 times X positive X squared, which is 225. 14 squared is 196. This is 28. So positive 28X, and this is going to give me negative X squared, and you have 169 negative X squared. So negative X squared, when this comes it will become positive, so you cancel these two. So you have 225, and from 225 you take away 196, so this will give you 9. Already you have a 9, 10, 11, right? You have 29 there, 15, 1, 10. Okay, so these two add up give you 29. So 29 plus 28x is equal to 169. Move this to the other side. So that means 169, you take away 29, 0, 140. So 140 is equal to 28x. So therefore x is equal to 140 divided by 28. Now 14 2s are 28, 14 10 times, so 2 gives you 5 times. So therefore what is x? X is equal to 5. Now x is equal to 5, you go up here, you substitute here, this is 5. You substitute 5, you get 9, right? Fine. You might be asking, why do we need to get these things? Of course, there is a reason why we have to get these things. Okay. Now this is what we have got. Now what I'm going to do is I'm going to take this point A and pass a line from A through the center O, and then let it hit the circle. Okay, that's exactly what I'm going to do. So from A, I'm drawing a line that passes through the center and it's the circle at, say, let D is already taken, so let me take this point E. Okay, now next I'm going to connect E with C. Connect E with C. Fair enough. Now what is created? Let me write that information here. Clearly AE is the diameter of circle O, and it is side of triangle ACE. ACE. Now this is the important step. By Thales theorem, if ACE is a triangle and AE is a diameter of the circle, then by Thales theorem, angle C, you can write it like this or you can write it like this, angle C is equal to 90 degrees. Okay, so this is the exact statement. If ACE is a triangle and AE is the diameter of the circle, obviously AE is one of its side, right? Then by Thales theorem, angle C is 90 degrees. Now, so this is what? This is clear 90 degree. Okay, fair enough. Now do you see this region AE? Okay, you see this chord? AC is a chord. Okay, now this is an interesting theorem. This chord is subtending an angle at E, and the same chord is subtending an angle at B. You see that? This is the chord that creates this angle E, and the same chord is creating the angle at B. It's a lovely theorem which I'm going to state here. We observe that chord AC subtends the angle at E and the angle at B. By inscribed angle theorem, angles subtended by the same chord are equal. So this means angle at E is equal to angle at B. Okay, go over here. Angle at E is equal to angle at B. Now watch here, angle at C is equal to angle at D, angle at E is equal to angle at B. So what are we looking at? By angle-angle similarity, triangle ADB, triangle ACE are similar. I'm going to state here, since angle at C is equal to angle at D and angle at E is equal to angle at B, by angle-angle similarity, triangle ABD is similar to triangle ACE. So by the law of similarity, what is the law of similarity? If I take this as R and this is R, this entire hypotenuse is going to be 2R, right? So this is the side, right? This is the opposite side to the angle. This is already got, this length is already got, right? So we can get the h. H is nothing but 169 minus x squared. X is 5 squared, so it's 169 minus 25, which is nothing but h squared is equal to 144. H is equal to root of 144, which means 12. So the opposite side has got h is equal to 12 units. Okay, that comes in handy. So what I'm going to do, I'm going to connect the opposite side, let me write that down, divided by the hypotenuse side is equal to the opposite side, which is 15, divided by the hypotenuse side. This distance is r, this distance is r. This is going to be 2r, right? 2 times r. So 2 times r is equal to 15 multiplied with 13 divided by 12. 3 divides here 4 times, 3 divides here 5 times. So 2r is equal to 5 into 15 divided by 4. 5 into 13, not 15, 5 into 13 divided by 4. Therefore 2r is equal to 65 divided by 4. So r is equal to 65 over 8 units. So this is the solution for finding r using what? Using Thales theorem and inscribed angle theorem. Right. So we've already got the value of h, which is 12. So this is a lovely question, and the same value of r we got when we applied the other algebraic technique using Aaron's formula, right, in the previous case. So thank you everybody, please like, share and subscribe.